2 out of part 5b. We on to the third.
This is the third day.
Fantastic. So we're finding the points of intersection of the lines with these equations. Points of intersection. Okay. So R1 has some lambda, where lambda is the proportion along D1. And mu is the proportion along D2. So R1 with respect to lambda should equal 1 minus 2 lambda in the I, plus 3 minus lambda in the J, plus 1 plus 2 lambda in the K. And R2 mu should equal minus 3 plus mu in the I, plus 4 minus mu in the J, plus 7 minus 2 mu in the K. Is that correct?
Yeah.
If we have an intersection point, then those I components will be equal to each other. If they have an intersection point in some space, the I component of R1 and the I component of R2 have to be equal. So 1 minus 2 lambda equals negative 3 plus mu is equation number 1 that has to be satisfied. 3 minus lambda equals 4 minus mu, that's equation number 2 that has to be satisfied. And 1 plus 2 lambda equals 7 minus 2 mu is the third equation that has to be satisfied. 2 unknowns, 3 equations, I can solve them simultaneously. If I add this one to this one, I should eliminate the mu's. Is that correct?
Yeah.
So if I write 3 minus lambda equals 4 minus mu, and add them together, 4 minus 3 lambda equals 1. 3 lambda equals 3, lambda equals 1. That's one solution. If I sub that into here, I get 1 minus 2 equals negative 3 plus mu. Mu equals 3 minus 2 plus 1. Mu equals, is that 2?
Yeah.
So they're my two solutions if using equation 1 and 2. If that satisfies equation 3, then we do have an intersection point. All 3 equations have to be satisfied. So equation 3 becomes 1 plus 2 lots of 1 is 2, equals 7 minus 2 lots of 2 is 4, 3 equals 3, bingo. Those 2 answers satisfy the third set of equations. Therefore, we do have an intersection point, and it will be when lambda equals 1 and mu equals 2. Will they be in the same place?
What do you mean, like?
At the intersection point of these 2 lines, will the I, J and K component be the same for both lines?
Yes.
Yep. I only need to pick one of these to sub into to find the answer, because I've got to find the coordinates of the intersection point. I know there is an intersection point. So if I pick R1,
we need to just
and I make
the unknowns by themselves.
lambda equal 1, because that's my value of lambda, it's equals to 1. That's going to be 1 minus 2
We won't add them, so there are no mu's, and there's just
in the
lambdas
I,
that we can deal with.
plus 3 minus 1 in the J, plus 1 plus 2 in the K, which gives you an answer of minus I,
So that
plus
comes
2J, plus 3K, is where the intersection point will be. Therefore, the coordinates of the intersection point will be negative 1, 2 and 3 is the intersection point. had I have put mu equals 2 into R2, I would have got the same answers, because that's the intersection point. Is that okay how that's happened?
If it says find the coordinates of the point,
Find the coordinates, yep.
so can we just assume that the first two are true? Like, do we have to check always?
Yeah,
Yeah.
because if these two answers didn't satisfy that third equation, then there is no intersection point.
Yeah.
Because all three have to be satisfied.
Oh,
Otherwise,
that's what
what
you're
we're saying is the k values, because they came from the k values are not the same k values
Yeah.
when lambda equals 1 and mu equals 2.
Yeah. Yeah. Okay.
Is that okay?
Oh.
Oh, there's a question.